But basically, when we have infinite limits and you have that 0 in the denominator, we are able to create something called a vertical asymptote. And vertical asymptotes have the equation x equal to some number. Because the y variable is free to be anything, the only restriction is on what the x coordinate has to be. The x coordinate has to be equal to a. So all this talk about infinite limits that we did over here, we're really getting vertical asymptotes. Okay. So for example, D, x equal to 0 is a vertical asymptote. When you look at part C, x equal to -2 is a vertical asymptote, right? Because the bottom here can't be 0. When you look at this one has no vertical asymptote, because after I simplified it, I don't have a 0 on the bottom. You look at this one, this x equal to 2 is a vertical asymptote. So anytime you get the denominator equal to 0, you're going to have a vertical asymptote, unless it can be canceled, like in B. Then you just get a hole. All right. So let's look at example 7. When you look at the denominator of example 7, do you guys see anything here? This is a something of two somethings. This is called the sum of two cubes. There's also a difference of two cubes. So if you have a cubed plus b cubed, or if you have a cubed minus b cubed, these have certain factoring properties. And there's a nice acronym to help you remember how it factors. So that acronym is called SOAP, S-O-A-P, okay? So here's how you do it. You're going to have an A here and a B here, an A squared, AB, B squared. You have an A here, a B here, an A squared, an AB, a B squared. So the shape of the factorization for both is the same. So what's the difference between this scenario and this scenario? The difference is, what are the signs in between here? So what does the S stand for? The S stands for same. So it's the same sign. So this is going to be plus because my original thing had a plus. The O stands for opposite. So if that was a plus, this has to be the opposite. That has to be a minus. And the AP stands for always positive. So let's put a plus here. So when we look at this difference of two squares, it's the same sign, right? So this guy here has to be a minus. The second one is opposite. So if I wrote minus there, I have to put a plus here. And the last one is always positive. So you have to put a plus there. So this is a sum of two cubes. There's a difference of two cubes. Yeah, here I'm teaching you now. Teaching you now. So yeah. So let's go back to our actual question over here. We want to find the vertical asymptotes. So when we find the vertical asymptotes, we could write f of x equal to x squared. I could factor that denominator. That denominator is going to be x plus 2, right? And then this would be x squared minus 2x plus 4. Now, the cool thing about the difference of two cubes is that the second factor here, this guy, and in particular, this guy, these guys are all irreducible. Irreducible means you can't factor it anymore. So when I try to find the vertical asymptotes of this guy, I don't have to worry about this because this can't be factored any longer. So now that I factor the denominator like this, do you guys know what the vertical asymptote is going to be? That's right, Luis. X equal to -2, because x equal to -2 makes this term right here 0. Okay, so this would be our answer.